6.1 The basic of counting. The product rule. If an activity can be done in 2 consecutive steps, and step 1 can be done in n1 ways, and for each of these ways, step 2 can be done in n2 ways, then the number of different possible activities is n1 times n2. Example 1. 2 dice are rolled, 1 blue and 1 red. Find the number of possible outcomes. The answer is 6 times 6. We have 2 steps, and each step has 6 outcomes, regardless of what is the outcome of the other step. Example 2. A committee of 4 persons has to select a president and a secretary. Find the number of possible outcomes. Step 1. Select the president. There are 4 ways to select a president. Then perform step 2. Select a secretary. Now 3 persons are available. So you have 3 choices. The multiplication principle applies, and we have 12 outcomes. Example 3. Find the number of bit strings of length 3. Solution. We do 3 steps. In step 1, select the first bit. There are 2 outcomes. In step 2, select the second bit. 2 outcomes again. Step 3, select the third bit. 2 outcomes. And altogether we have 2 cubed. Example 4. How many functions are there from a set of 4 elements to a set of from a set of 5 elements to a set of 4 elements? Solution. A function corresponds to a choice of one of the 4 elements in the codomain for each of the 5 elements in the domain. So we can do this in 5 consecutive steps. The product rule applies. Each step has 4 outcomes. Altogether, the product of 5 fours. It is 4 to the 5th. The sum rule. Let X be a set. Then this way, X between 2 vertical bars. So this means the number of elements in X. In other words, the cardinality of X. If 2 sets X1 and X2 are disjoint, that is, the intersection is empty, then the number of elements in the union of X1 and X2 is the cardinality of X1 plus the cardinality of X2. Example, a 6-person committee composed of A, B, C, D, and E and F is to select a president and a secretary. In how many ways can this be done if either Alice or Ben must be a president? Let X1 be the set of all selections in which Alice is the president, and X2 be the set of selections in which Ben is the president. First, we'll determine the cardinality of X1. Alice is the president in any of these selections, any of the remaining 5 persons can be the secretary. So x1 has cardinality 5. Similarly, x2 has cardinality 5, and x1 and x2 are disjoint. No two committees are equal. No two committees, one of x1 and one of x2, are equal. So the addition principle applies, and we have the cardinality of the union is the cardinality of x1 plus the cardinality of x2, and we end up with 10. Example 6. A 6-person committee composed of A, B, C, D, and F is to select a president, secretary, and treasurer. In how many ways can this be done if either Alice or Ben must be a president? Solution: let x1 be the set of selections in which Alice is the president, and x2 be the set of selections in which Ben is the president. To count the selections in x1, we perform 2 steps. First, select a secretary. There are 5 ways to do that because Alice already has a position, the president. And then perform step 2, select a treasurer. 4 ways here to do that because 2 persons now already have positions. The multiplication principle gives that x1, the cardinality of x1 is 5 times 4, 20. In a similar way, we count x2. There are 20 elements, selections there too. x1 and x2 are disjoint, so the addition principle applies and we obtain 40. Example 7. A 6-person committee composed of the same persons as before is to select a president, secretary, and treasurer. In how many ways can this be done if Egbert must hold one of the offices? Solution 1. So we can consider 2 different solutions. In solution 1, let x1 be the set of selections in which Egbert is the president, and x2 the set of selections in which he is the secretary, and x3 be the set of selections in which he is the treasurer. In order to obtain a selection from x1, we perform 2 steps. Select a secretary, 5 ways to do that because Egbert already is selected to be the president. And then perform step 2, select a treasurer, 4 ways now to do that because 2 persons already have positions. Multiplication principle applies and gives that the cardinality of x1 is 5 times 4, 20. And we count similarly the cardinality of x2 and x3 and obtain the same number. These 3 sets, x1, x2, and x3, are pairwise disjoint. Hence the addition principle applies and we get 20 plus 20 plus 20, 60. Solution 2. Any of the selections which we want to count can be obtained in 3 steps. In step 1, we select a position for right bar, 3 possible ways because 3 positions are available. Step 2, select a person for the next position. 5 persons are available, so 5 choices here. And step 3, select a person for the last remaining position. Now 4 persons are available. We have 4 choices. And the multiplication principle applies. 3 times 5 times 4 is 60 selections. Again, the same number as in solution 1. Inclusion-exclusion principle for 2 sets. If x and y are finite sets, then the cardinality of the union of x and y is equal to the cardinality of x plus the cardinality of y minus the cardinality of the intersection of x and y. The proof: the cardinality of x counts the number of elements in the difference of x and y, and the number of elements in the intersection of x and y. The cardinality of y counts the number of elements in y minus x and the number of elements in the intersection of x and y. So the sum will double count the elements in the intersection. So we have that this sum is the cardinality of the union plus the cardinality of the intersection. From this equality, we obtain the equality in the beginning simply by subtracting this number, the cardinality of the intersection, from both sides of the equality. Example 8. Our 6-person committee is to select a president, secretary, and treasurer. How many selections are there in which Ben is a president or Alice is secretary or both? Solution: let X be the set of selections in which Ben is the president, and let Y be the set of selections in which Alice is the secretary. We have to determine the cardinality of the union. Applying the multiplication principle, we obtain that the cardinality of x is 5 times 4, 20, and the cardinality of y is 5 times 4, 20. We did such count in previous problems. The set intersection of x and y consists of the selections in which Ben is the president and Alice is the secretary. Clearly, the cardinality of the intersection is 4 because to fill out a selection like that, it remains only to select treasurer, and that can be done in 4 different ways. Hence, applying the previous formula, we have 20 plus 20 minus 4, 36. selections. Example 9. How many bit strings of length 8 starts with 1 and ends with 0, 0? Solution. Let X be the set of strings of length 8 that start with 1. And let Y be the set of strings of length 8 that end with 0, 0. We have to find the cardinality of the union, because here we have OR. The cardinality of X is 2 to the 7, because the first string is fixed. So 7. The first bit is fixed. 7 positions must be filled, and for each we have two choices. 2 to the 7. Y. The cardinality of Y is 2 to the 6, because in any string from Y we have two zeros at the end, so 6 positions, bit positions, has to be filled with these 2 to the 6 choices. The cardinality of the intersection. In the intersection we have 8-bit strings that start with 1 and end with 0, 0. So there are 5 positions to be filled, each with two choices, so 2 to the 5th strings in this set. And then the formula applies, inclusion-exclusion formula. We have the cardinality of X is 128. The cardinality of, so this 2 to the 7. The cardinality of Y is 64, and the cardinality of the intersection is 32. So the result is 160.